Let's take a look on this frequency response of a low-pass filter. Low-pass filter, as you can see from here, it actually allows low frequency to pass while attenuate the high frequency. So this is a very easy definition of low-pass filter. Let's take a look on this diagram in order to understand better. Let's say there are 4 signals at 4 different frequencies, 10, 20, 30, and 40 kilohertz. When they actually pass through the low-pass filter with a cutoff frequency of 25 kilohertz, what happened after that? Only 2 signals will be appear at the output of the filter. From here, you can see that only the low frequency 10 and 20 is able to appear at the output of the filter, while the signal at 30 and 40, they are actually antenna away. So this is actually a quick characteristics of low pass filter. Let's take a look on this lump element. Okay, so most of the time we actually struggle, okay, to determine whether is this a low pass filter or a high pass filter. Let me explain in deep detail so that you don't need to remember this. For example, okay, so how we compute the reactance of inductor, how we calculate the reactance of the capacitor, the equation are over here. So let's study at 2 frequency. At low frequency, okay, so when the frequency is low, so typically the reactance of the inductor will be very small. Let's say 0.1 ohms. While for C, okay, let's say the frequency is low, so basically 1 over very low frequency, this will be a very huge number because capacitor is like picofarad, nanofarad, etc. So basically overall, this reactance of capacitor will be a very big number. Now, let's imagine this is actually a current. When they actually flow over here, you can see that this is actually a low resistance. So most of the current will actually flow this path, which means that at a low frequency, majority of the signal will appear at the output of the port, while very less low frequency will want to travel this path because this is actually a very high resistance. Now let's take a look on a high frequency. Okay, so when the frequency is high, you can see that the total reactance of the inductor will be very huge. As for capacitor, when the frequency is actually very high, the total reactance will be very small. Again, imagine this. Okay, the signal at high frequency actually travel this path. And basically, there are actually 2 paths. So from here, you can see that this is actually very high resistance. The signal will not want to travel this path, and the signal will prefer to travel this path as this path has a lower signal, so-called lower resistance. So hence with this, you can imagine that the high frequency actually will be shunned to the ground. As for the low frequency, they will be able to appear at the output of the low pass filter. So basically, this is actually sum up what I want to explain. At low frequency, okay, everything will actually pass and reach at the output of the port. While at the high frequency, they actually will shunt to the ground and therefore they will not appear at the output of the filter.